So once again, my name is Sasse. I'm the Astronomer-in-charge, and I'm very delighted to do this together with my co-host Leigh, our software developer from iTelescope. He's developing a beautiful new platform, which hopefully you'll see very early next year. Leigh, will we?
Yes, the first release is scheduled to be either the very late of first quarter next year or just after, just early second quarter.
And if you have any questions, just put them into the Q&A. We'll leave them for later. Okay, so let's jump right in. I'm going to share my screen with you now, and let me just get to the right screen here. Yes. So those of you welcome who've never been with iTelescope, this is our homepage, itelescope.net, and here you have things so also amazing Astro Adventure. Let's go Chile. Click on it. It's completely new. Chile is probably the most from astrophotography has the most clear skies, the best. Doubtlessly they have 25 out of 30 clear skies per month. So for the first time, we're going to host in Chile. If you're interested in an adventure, we still have 1 or 2 places left. So go and explore that. And here you can see all the other things that we do. We have free telescopes, affordable, and so on. We'll briefly go through that, but I'm going to jump straight in because if you go on the very right-hand side, you can join here. If you want to, you can join there. You can see what we're doing, and then you can log in. And when you log in, you get to what we call, you get into what you call the Launchpad. That's what you're seeing here. This is the Launchpad, right? So you can see there are our observatories. And on the left-hand side, you can see a map of the world, and you see some red dots, and that's where we have our observatories. The one I was just talking about is in Chile. That's Deep Sky Chile. You can see that's the apparent position of the sun. There's the apparent position of the moon. It's on half now, right? You can see the illumination. That's where I'm up here in Vancouver at the moment. You can see that is our Californian one. That is SRO, Sierra Remote Observatory, and then that's New Mexico. That's Spain. We have 2 observatories in Spain right now, and that's Australia. That's the early hours in Australia. It's just going to get dawn there. You can see that. That's exactly what's happening in Australia. You can see, typically, you would see the local time up here. Everything that we do in iTelescope is always local time. It's local, local, local. Just think of local time. So whatever you see there is local time. You also have the UTC difference here from our universal team time. We have someone from London here, so he's on the universal time. Except if in summer, they're not on universal time. They have summertime as far as I remember. And then you can see here typically the opening and closing times for the observatory. Then you can see the position of the moon. You can see here the moon is rising. It's plus 41 degrees. That's the moon illumination is 46%. And there the sun is still at -9. So it's slowly getting dawn there. And this is very good here. You can click on here and you can see the weather. Whilst that is coming up, I will just jump back and just show you what else we have here. So that's the map of the world. Here you can see start planning here. I'm going to go into that in a moment, and then download my data. Here's your support and your account overview. Okay, hopefully we are going to be in here in a moment. Whilst that is going, I'm going to show you something really cool. So once you've subscribed, you can click on any of these and you've registered, and you can see what other people are doing. So I'm going to do that right now. I'm just going to click on T8, and that's a telescope, one of our telescopes. You can see what it looks like. And if I go here and on the left-hand side, they all look the same, the menus. If I see here system status and I see preview last image, sometimes you can see it and sometimes not. Okay, well, that's just been taken now. So there's nothing special to see. A while ago there was, but I don't know when the latest image was taken. So maybe we're still lucky and we can see something now. Nice. Just trying to see now. Oh, yeah. Does anybody know what this is? Does anybody have an idea what this is? Let's see. Let's have go into the chat. Let's go to the chat and see if anybody, yes, that's it, exactly, Edwin. You're right, Michael, Tarek, they've got it. B33 is the correct designation, you got it, and so on. 6 observatories, yes, that's right. So just put the questions into the Q&A, okay? But you're right, Horse Nebula, everybody's got it, right? That's probably one of the most intriguing side. You can see how beautiful it's coming out. That's from the emission nebula. That's a dark nebula. That's the flame nebula, as you said. That's B33. That's the correct designation for it. Absolutely good. Yes, it's probably the favorite target apart from Orion that nearly everybody has, right? Okay, so we've done that, and I'm going to click on another image here on T69. I'm doing that for a special reason because the other ones are so-called, they have filters. I'll explain in a moment what they are. But this is a single shot color camera on a telescope. So that gives you, just like your phone or whatever, gives you a color image. So if I go on here and say system status and I say preview the last image, let's have a look and see what that is. Okay. I'm going to let you guess now. This is a bit more tricky. This is a color image, really as a prop. Anybody? Yes, Etta, you got it. You got it, Tarek. Yes, and Jorge, that's right. Etta Karina, absolutely. You good. You're absolutely right. This is Etta Karina. And I was actually the culprit because I took this exactly about 1.5 hours ago because I thought, you know what, I'm going to jump on here and I'm going to see if I can't show you something nice. And then let's do some image processing live now very quickly so I can show you how easy it actually is to do this, right? So yes, you are absolutely right. This is on T69. So what did I do here earlier? So what I did here is, you can see here it says image and plan. I just clicked on one-click image. It's so easy to do. And I went down here and I just clicked on submit. That's all I did. And what it does then automatically, it takes 120-second images, 3 of them, right? 3 of them. So your total exposure time is actually only 9 minutes, right? 9 minutes. And then, yes, it appeared in, I went to the download. You see where it says my images. I went there and that brought me, I won't fill that out now, but yeah, that gets me to another window. And when I say login here, that's your data service. You have all the images there. And then I went to my T69 folder. In the beginning, you wouldn't have anything. And I'm just going to show you that this is really real that I've done this.
I think you need to click on the designation number, not the actual folder.
Oh, thank you. Thank you, Leigh. Absolutely. And you can see here, I have some already. And this is the correct designation. You can see here is the date, in fact. That is today's date, right? That is the 16th of December. And that's what I just took. So this is real. This is real what I'm going to show you now. And then I just quickly downloaded this on my computer. And I'm going to show you what that looks like. But before, because we just had the Horsehead Nebula, I have to show you how beautiful the Horsehead Nebula can actually look when you really go cuckoo, right? When you go cuckoo and you take many hours on a single shot and you stack them, you get a very deep image. That just came off this morning. That's on a private system, but it's also a RASA, by the way. And then you get these crazy, you can go so deep that you see all the fine details of the Horsehead Nebula, right? So that's achievable, all these things, right? Okay, so I'm going to very quickly just open Astropixel Processor. Don't worry if you've never worked with Astropixel Processor. I will do another tutorial on it, but I do want to show you quickly how easy it is to just combine a color image, which we're going to do now. So when you come into Astropixel Processor, without explaining all the details, here is where you put your directory, and I put this already put in the correct folder, so I can easily get my images, and that's where the processed images are coming. So I just say open there, right? So I'm just going to disable multi-session processing because we're putting them all into one. I'm going to just call this, just suggested it, Eta Carina color. You know, that's it, color. And take the American spelling. Sorry about those. Canadians would be with an O or U in there, and the British guys too, of course, but we'll take the American spelling here. And I'll open this, and you can see here are my 3 images that I took just a short while ago. I choose them all. Okay, we're going to load them very quickly. Okay, I'm going to click on one of them so you can see what they actually look like. And that's what it looks like, a little bit dim, but don't worry. I'm going to go here to integrate, which means we're going to stack them, reduce the signal to noise ratio, and all I have to press is integrate. There I've got the name. I just misspelled this. I just did that, and just say OK. So give it 1 or 2 minutes, and it's going to stack them, and then we'll see what comes out of it. And that's all you need to do. By the way, whilst we are running, these images are in so-called FITS format. It's for those of you who are new, this is very strange. It's a format that the astronomy community uses because there are a lot of there are a lot of data in there. We call this metadata that are hidden inside the image that are very useful. For example, the observatory, the time, image details, and so on. And there we already finished. That's the stacked image, but you can see there's a lot of green in. Now the green is natural. Don't think that green isn't light pollution. It really comes from the glow of the atmosphere. We have very good skies inciting spring, but this is really normal that you get a bit of this green glow, which we're going to remove now. So how I remove this is I finished the picture. That's 3 pictures stacked. You get a much better signal to noise ratio. I'm just going to go into tools here and just say here, where is my, I'm just going to say calibrate star colors. That's all you need to calibrate the star colors, and say yes of this image. It says, wait a minute, you first have to calibrate the background. That's what it tells you here. So how do we do that? We have to tell it what the background is. I'm just really going to overexpose now. That's just the window that we have here. I'm going to overexpose it so I can see where my background is. I'm going to put some markers here. You see these small areas? I'm just going to say these, I'm choosing very dark areas. I'm going to say these, that's all my background here. And there's also something there. And you have to take about 6 or so, which I'm going to do 1, 2, 3, 4, 5. I'm going to put one more here and maybe one more. Yeah, let's put one more down here. And I try not to hit too many stars, right? And then I just say calculate, and that's going to even out the background. You see how the green disappeared immediately, and that looks a lot better now, doesn't it? And I'm just going to de-stretch it again so that we can see it better. There's your Eta Carina. It looks much better in color. So I say OK and save. I'm just going to do that. And then we will finally just get the correct star colors. How do I do that? Well, it's quite simple. I'm also going to put the saturation on, by the way. You see, I'm marking here saturation. It gets better color. See that? Now it's on saturation. I forgot to do that. And I'm just going to choose a few stars here and there of the background. And I'm just going to say calculate. So what it's doing now, it's saying, well, those stars are the stars from the Milky Way. And you see now it gets the nice red color. So that's definitely correct. We get a star plot here. Don't worry about it. You can even shift this a little bit more to the red, which I'm going to do just a tiny bit more. And just to recalculate. And that's it. That's it. So now we can save this image too. We can save it first here if you want to, or save it as a FITS file. So that's the astronomical. And then you can export this image already and send it to your friends. That's so easy how it goes. By the way, we will, I'm just saying that to our friend John and Sikanda and Walter, in case they're there. We're going to include these 3 images for you to download as a small surprise from iTelescope. So we will put this as a link together with the recording so you can do exactly what I've just did and practice it yourself. Okay, so we'll do that. Okay, so we'll add that. I just have to remind myself to do that and give you the link. Okay, so we just say okay, and it exports the image and you're done basically, right? It'll be in your folder here, and there is your color image. Now, how long did that take? 5 or 10 minutes and you're done, really. And you got a beautiful image there. So now that you've seen that we've done all that very quickly, I'm just going to give you a walkthrough of how to operate these telescopes, right? So in order to do that, I mean, it's no fun just to click on a telescope. You need to know what to do. And if you click on start planning here, that really helps you. Okay, so you've got all it's called the iTelescope planner, and you've got all the different observatories here, right? As someone said, we have 6 at the moment. That's completely correct. Yes. So since we've already been in Siding Spring, I'm going to choose New Mexico skies. And if I press here search, here it's going to give and show you the most important winter targets, right? So they are really beautiful. So I'm going to give you a chance at the moment. Just look at these. By the way, Andromeda is getting a bit late now, but I'm going to give you a very quick, well, go and put in the chat what you would like to image or what we're going to program. So you tell me more what you like. But remember, this is a northern sky. So it's a northern sky. Eta Carina is the southern sky. So we are now New Mexico sky. So just choose one of these, please, that are on the first page. Okay, I know there are so many. Okay, but just choose. So we have the Pleiades there. Well, Andromeda maybe, Rosetta we have. Let's see if there are any favorites here. The Witch Head, yes. Okay, the Pleiades, M33. I'm listening. Pleiades second. Okay, we're listening. Any more? M33, 2. Triangle, that's again one, that's 3 for it. Now, okay. Oh, Philida also. Everyone wants M33. That's good. Here's a cell one, 6543. That sounds good. I don't even know what that is. I don't have all these. The bold is M81. Okay, good. Well, I've got the majority for the triangulum or M33, which we're going to do. Okay, I'm going to cut that off now. Bold, okay, that's 2 for M81, but we'll, okay. Look for N6543. Yes, I will look for N65. I'm just curious which one that is. I'm sorry that I don't have all the catalog like you do in your head. So I admire that you know that. I don't. But anyway, good for you. Okay, so I'll look 6543 up because it's easy to remember. I'm very curious now. Okay, so we're going to go to the famous triangular galaxy. I'm just going to expand this window a bit so you can see this. There we go. Let's do that one. It's a beautiful one. I also imaged that just a month or so ago directly from my light polluted home, right? So that's the one. So you can see a little bit about it. So what do we see here? You can see there's an arrow pointing up. That's the rise time. That's when it is above 30 degrees. That's the highest point. We call that the transit or meridian or so on. That's when it crosses the east-west line, right? And that's when it disappears. So that's just after midnight. So it's getting just the first part of the night where we can use it, right? Or where we can still image it. The size is 1.1 degrees. That's twice the diameter of the moon. That's huge, right? It's quite big, actually. Never think so. And that's the distance to the moon. Now, that's not that important. It's 146 degrees because the moon's getting quite low now. We're just on 46%, if I remember, right? So there you go. And in order to now, so we've decided together, it was democratic, that we're going to do this, the M33 or the triangular galaxy. And I'm going to click now on Telescopius, and I'm going to see how we can actually image this in what telescope. There you can see it appears again. Now you have to be a bit careful here. If you've never used Telescopius, it's beautiful to use. It's really beautiful because everything is really in pictures. It's easy to understand. And you can see we're in New Mexico skies here. Just please be careful that when you jump from our planner, which was programmed to be New Mexico skies, to here sometimes the observatory doesn't follow through. And that has to do with the browser, right? So just make sure, then if that happens and you're in another, just make sure you're in the correct observatory. In this case, I'm going to click on New Mexico skies. Sometimes I've also noticed that we have what I would call a sticky browser that just doesn't want to leave one place. Then go and use the so-called incognito mode. That's a private mode of your browser, and that will get rid of that problem. It's sometimes annoying, okay? So you can see we're here in the last quarter. That's the date today. And here, I'm just going to show you this. Let me just expand this a little bit. Here you can see the 30-degree line, and you can see when it rises and when it sets, right? The rise time and the set time. So you can see here it's definitely high up in the early evening when it gets dark, and that's the highest point. So we have until just, well, probably till 12:30 a.m. to do this. Okay, now the question is, what telescope? How do we even know? Well, here is what we call the virtual telescope or field of view. It's like a virtual telescope. And if you click on here, you see that icon for the dome. It's already an iTelescope. You have all these different telescopes that you can use. Now, we have to take the one with the US flag because we're going to take the ones in New Mexico. And some objects are visible in the northern or southern hemisphere, for example, the Orion Nebula or the Horsehead or so on. But in this case, the triangulum is fairly, it was a declination 30 degrees. So it is, that means that's a latitude. So it's mainly observable from the northern hemisphere, can also be observed from the southern, but it's quite low there. It's quite low. Okay, so I'm just going to look here and just click on different ones. Let's try T24, and you can see if I click on T24, it's so big that even T24, which is a 24-inch telescope, doesn't quite take it, although it's probably good enough to do that. Let's try another one. Let's try T11. So you can go through different telescopes here. Well, let's take T68, which is also a color camera. So T68, for example, would work perfectly. But I actually want to use a non-color camera because I've just shown you how to operate one. So T14, well, maybe that's a bit small in there, but let's use T14 or T20 anyway, just to show you how to do this. So we've chosen a telescope, and you can write those telescopes down, and we chose the target. Now, all we need to do is go to that respective telescope and program it. Okay, so let's do that. So I'm going to go right back here, and I'm going to go into New Mexico skies. That window is closed at the moment. Why is it closed? Because it's daytime there, right? So I'm going to scroll down to T14 or T20. Those are our wide field telescopes. You see that's quite, well, those of you who know a bit about telescopes will see that's a wide field because it's a smaller telescope and so on. Usually the big telescopes are the deep sky telescopes, right? Okay, so let's do this. So I'm going to go, remember we used the one-click image before, so if you want to do nothing, it'll do that for you. You can go in here and you can just click the image. But in this case, we're going to do it a bit different because we're going to plan this for the telescope, because this is visible right now, and you will see that there is no M33 because that's not visible right now. Anyway, we're going to take the observatory walls, right? If we're going to take it. So the system's not intelligent enough that it's going to show you, say, sorry, it's closed now, but we show you what would be visible if there were a solar eclipse right now. Okay. Okay, so let's go anyway into deep sky objects. That's your main menu, deep sky objects. I'm just going to give it a name. We'll just give it we're going to call it M33. And that was also our target name, M33. And I'm just going to say, look up the coordinates for me, which it does, you see? So as soon as I typed in here and click look up, it looks it up, right? That was what we remembered, and it tells you again, you can image all the way up to 12:44 a.m. right tonight. Good. We've done all that. You can click back on here if you're unsure whether this was the right telescope. If you click back on view object framing, it'll take you back into telescopes, which I won't do right now, and it'll show you the framing once more. Quite useful if you are at a telescope and you already know the object that you want to use, and you just want to be sure that the frame is correct. You can do that there. There's our object name. And now I'm just going to put in some filters. But before I do that, I'm going to just give you a very quick excursion on filters and why we use them. So the main reason why we use filters is because the colors in the universe are very different to what we used here on Earth. On Earth, we're used to that most things are really in the yellow and green, like, you know, chlorophyll or so on. That is where the solar spectrum is at its maximum. We have maximum light, and that's why everything that grows, you know, all our biosphere is very much around the yellow-green, the yellow of our sun and the yellow-green, because we, you know, that's a maximum in the spectrum, and our eyes are actually geared for that too, right? So if you look at the human eye here, where we are most sensitive, you will see it's right about here. That's just the difference between day and night vision. And you'll see the cameras can look a lot further. This just says CCD, but the CMOS are the same. They can look, and the sensitivity goes way up now. You should upgrade this, but it goes way up the efficiency, and they go far into the red, which is very good for the universe, because in the universe we have mainly hydrogen, and the hydrogen lines are very much in the very dark red, actually. Yeah. So we have the hydrogen line, and these beautiful, for example, what you saw on the horse head, this red comes from these so-called emission from ionized hydrogen. And then we also have oxygen lines, we have hydrogen beta and sulfur, we have many, many other lines, but those are the prominent lines. And then if you look at the stars, they are very similar to the light that's emitted from our sun. And that really gives the colors, right? The colors. But mainly if we go for emission lines, nebula, our eyes don't see much. If you were to travel through the Horsehead Nebula, you'd be quite disappointed, because the typical distance between those ionized hydrogen are in the hundreds of meters, 100 feet, what do you want to say, even up to 1 mile or so. It's a perfect vacuum up there. It's so much a vacuum that we cannot reach that type of density on Earth, no matter how hard we try. And that's also why we get these special lines, by the way, like the oxygen line. We can't reproduce that line on Earth because the density is so low up there that these very rare lines can exist up there, which don't exist on Earth. That was a small excursion, but that's what makes the universe so interesting, so very different to what we have here on Earth. Okay, so that's the reason. So that brings us to the color filter. Now, this is a bit of an old-fashioned filter. This is where your telescope would be. There's just a lens here, and we have a filter wheel here. And you can see this is typically a 5-position filter. Usually we have 7-position filters and more. And there's a red, green, and blue. And then we have other ones. You would usually have, that's a luminance filter. That's your black and white. That gives you everything. And then we have another filter there. And usually you would have so-called narrowband filters. Those are the filters that I just, the bands that I just showed you of hydrogen alpha, oxygen, ionized oxygen, and ionized sulfur. So they would usually be 7 or even more, depending on what you're doing there. And there's also something interesting that's a bit different about these cameras. You can bin. The word binning is really a strange word, but it's like combining pixels together. And why would we do that? Well, it's like this. If you take a black and white image, you're encompassing all the colors. The old cameras that we had that were so black and white, those of you who went and did some photography development, I'm sure there were who would have their own dark room, not light room, but dark room, that's what we call them, and would make these beautiful black and white images. That's what it was, right? It encompasses blue, green, and red, blue, and green, all the colors, the primary colors. And if you separate these colors, you put filters in front, like a red, green, and blue, you can start separating them. And then it's useful to bin, because if you put pixels together, they will they will capture much more light. So you get much more signal, but you lose some resolution. But the resolution you'll get through the black and white, which we call luminance. If you just remember, you put the luminance and then we, like a painter, we just splash in the colors later, right? Just see it more like a happening where they used to have, they just splash colors onto a, creative art. That's what we're doing. We're splashing the colors later onto it. And that gives us the color because we don't need the details in the color so much. So that's just a nice trick. And that's why we use binning, okay? Right. I think that's one more thing. Our images are also calibrated. Calibrated just means it takes care of artifacts. It takes care of imperfection in the optics. All optics are imperfect. They all are imperfect. They have what we call vignetting. You can see they have astigmatism. They have all kinds of things, right? Everything that you can imagine as you get older with the eye certainly happens with optics too. Why you go to why does Leigh wear glasses? He can probably tell you what's going on there, right? But it's the same with optics. We have absolutely the same problem, right? Anyway, okay. And then finally, very quickly, just about the setup. It looks strange, these telescopes, right? They have a sort of a small camera on top. We call that a guide camera, right? It's a guide camera and it's guiding the telescope very precisely because no mount, we call these things mount where they sit on, is precise enough really to make long exposures, right? That's why we guide them, okay? And that's, I think, enough. And we can get back now. And actually with that knowledge, we can try and program something. So here I told you about the luminance filter. That's your black and white. Let's just put 1 there for now. And I'm just going to say, well, whatever time, I'm going to say 180 seconds, so 3 minutes is fine. Binning 1, remember, that's our resolution. And then we're going to add red, green, and blue to it. I'm just going to put 1 red, please, to it. 180 seconds, okay? And now we do bin 2, right? Remember, we get more signal that way. And 1 green and 180 seconds. There's a little bit of repetitive work that we have to do. But those of you who use their own telescopes, Nina and whatever program you may use, Voyager, you'll be used to this. This is exactly how you populate. Oops, that's 180 seconds. 1 second. Typing here 180 and binning 2. Just make sure you have the binning correct. You can add other rows. You could do narrowband. We won't go into that. It's all fine. 3, 6, 9, 12 minutes here. But we should actually take more because as you just saw with the Eta Carina, if we take more images, the dark parts come up much better. The noise goes down. That's why you do that. So we can repeat this 5 times. So that gives us exactly 1 hour, right? This is 12 times 5 is 60. So we have 1 hour. So I should just, I forgot to say that. So we repeat this 5 times, this whole event. And then I say, create a plan for later. It's just overriding what I just did. We're all good. And now I go back and say, make a reservation. So we need 1 hour of imaging. So I'm just going to drag some time slot here. That's for tonight. You see the username is there. And I'm just going to start at 10 p.m. And usually what you would say 1 hour, that gives us to 11 p.m. But now it's like this. The telescope has to know where it slews, it focuses, it changes filters, it does all kinds of things. That takes time. And it takes about 50% of that time. So if I have a 60-minute, as you say here, I should actually reserve 90 minutes. So that's what I'm going to do. So I'm going to have to select my plan. You see, I have to say which one it was, M33. And I'm going to make this 90 minutes long. Okay, so from 10 to 11:30, I can make a comment here if I like to. This is for training. And I can also reschedule, which is really convenient. So if the roof is closed tonight, it will try and reschedule you for another night. By the way, Leigh can explain to you what happens if the roof suddenly closes in between, right? What happens?
Yeah. So if you get a puff of cloud or a bit of bad weather and the roof has to close, our systems will detect it. It will put your the execution on your plan on pause, on hold, and we'll wait for the roof to open again. And when the roof opens up again, it will actually discard your last exposure, because we'll assume that the roof closed during the last exposure. We'll discard it, retake it again, and just continue resuming your imaging session.
Very good. And I just saw a question in here. So yes, you add up 50%. So 60 minutes, you add 30 minutes and so on. That's a good rule of thumb. We're going to improve, Leigh, once he gets to it, we will improve that whole thing much easier, so it does it automatically for you, probably. Isn't that, or am I promising too much, Leigh? I don't know.
No. It's absolutely in our release schedule. So all you need to do is select your start time.
Yes. Yeah. So we will do that.
And even more down the future, you wouldn't even need to guess when the target is. We'll actually display a little graph and say, well, this is where your target is visible. So you won't ever be able to make a reservation when the target is not visible in your plan.
Isn't that fantastic? And that also goes for the future, right? As time changes. So that's all good news. Right. So that's all good news. So that's all coming up next year. Can we say next year? Can we?
Yeah, absolutely next year.
Okay. Yes. Mark, read. You hold Leigh accountable for that.
Oh, well, this is why here we're a member-based organization. So a lot of the features that members request for, we will do that.
That's wonderful. Cheers to Leigh. Yes, I agree. Cheers to you. We're going to cheer you on. Okay, I can do this. Great.
Thank you.
Okay, so all we need to do now is confirm the reservation, which I'm going to do now. And there in golden color, you can see there's my reservation, which I can move around even if I want to. I mean, we don't have much possibilities, but I can move it even to the next day. And there's, by the way, something I should mention again. This is all local time. Remember, we're in local time. And also our day, Friday, the 16th of December, which is today in New Mexico, is defined as such for the whole night. So we don't change, we don't do the date line at night because it gets confusing. We just leave it. So you're just reserving on this day. That's what it means, just to make it simpler, right? So I could shift this in the early morning if I wanted to. It would be the 17th, but it still is recognized as our night of the 16th, okay? And that's it, basically. That's it, you're done. That's all you need to do. And you can go to sleep, or you can also go and log in and watch your telescope. You can watch others and so on. And then you can take the images and just go back to what I've just shown you. And I'll show more detailed image processings on LRGB, how to do that in future. And that's basically it. Then you can download the images as I showed. You just go to My Images, you log in as I just did, and you go to your respective telescope, which in this case would be T14. And there you can see, it also did the moon, by the way, and you can download all your images. Very nicely done. It's a new interface, isn't it, Leigh? So it's
it is. It makes it
much nicer now, this whole interface. So you can easily select them and download them, and you have to you still unzip them. Yeah, that's right. You still unzip them because they're compressed. So don't forget to unzip them. And I think that is basically all. Very quickly, the membership, what is very nice is, let's just show you where exclusive offers are. Full moon is something really nice. So we have this full moon happy hour. Let me just talk a little bit about the moon. So what is so special about the moon? Well, there's something special maybe that many people don't actually know, is at the moment in the Northern Hemisphere, you do know that we have winter, and you do know that in winter, the sun is very low. So usually during full moon, or usually it's always during full moon, I should say, the moon is always on the opposite side of the sun. So when the sun is very low in general, but also low, it gets very low below the horizon. The moon is high up. It's high up. We call it, that's like a high up latitude. We call that declination. So it actually means during winter time, during full moon, the moon is a real nuisance on the Northern Hemisphere. Now here comes the lucky part, because iTelescope has telescopes on the Southern Hemisphere too, and the sun is very high. It's summertime there. The moon is low correspondingly on the southern hemisphere. So during full moon in wintertime, always think of the opposite of the sun. Okay, so when the moon is high here in winter, go and observe during full moon on the southern hemisphere, right? And it's opposite when we have summertime. When we have summertime, then it's very good during full moon to observe on the northern hemisphere, because then the moon is at -20 to -30 declination. That's what we see. It's like your latitude, right? So it's always the opposite. And then during spring and autumn, it's balanced, right? Because the sun is more or less balanced between the northern and southern hemisphere, so is the moon. So there it's at 0 degrees declination, like 0 degrees latitude, think around the equator. And it doesn't really matter whether you go to northern or southern. You can go quite, as long as your targets are fairly high north and fairly high south, you can actually image during full moon on both. And that's good. If you remember that, you can do quite a lot. So at the moment, just to summarize, it's very good to go and image on the southern hemisphere. In summertime, northern hemisphere. There you go. And that makes it, that makes the full moon happy hour really worthwhile, because for no charge, you can go there. Is it 1 hour now, isn't it? For 1 hour?
Yes. Yeah, 1 hour imaging sessions every 18 hours.
Thank you. Every 18 hours. So you can do that. And okay, very nice. So that was a small, okay, sorry, that was a small excursion on the full moon, right? So that's nice. And then you can just go and you have the pricing for standard plans. And if you don't know that, so we start at $40, right? And the price per telescope lowers. It's like you get more discount, right? The higher your membership plan is, right? Telescopes. So you have the premium telescopes you also have, and those are the telescopes that are more expensive, of course. And then you have all the prices there for them too. And also what I should tell you, which is quite nice, is we also have premium images for you. So what are premium images? So premium images are every 2 weeks, full moon and new moon, very easy to remember. You can download according to your plan. You can download images. In this case, we, for example, have the Pleiades, and this is done with a one-shot color camera. And these can get quite intense, by the way, 36 gigabytes. We just heard, by the way, that some members have problems downloading all of this in one go. We're going to work on that next year, because data is just becoming more and more. And it's really good data, but if you have a slow internet speed, sometimes it gets a bit problematic, right? Leigh, it's something that we're going to tackle in the future, right?
Yeah, absolutely. Even now, it's on the back of my mind on how we can get this data to you if you have problems.
Yes,
So,
yes.
yeah, we are aware of it, and we are trying to come up with a solution.
Okay, and here we split the Pleiades, for example, this beautiful image into 2 parts, right? So the next part is coming there, because it's just so much data. And I think this is 12 hours of stacking color, 12 hours. And that's why why you get all these fine details that you usually don't see on the Pleiades. So that's also a good reason why you could join iTelescope, even if you don't want to use the telescope, just to use premium images is a big benefit. And usually when I will give, see that I give at least one free image processing tutorial. I think before Christmas we'll probably not make it, but I usually try and do one free imaging tutorial, so you can see that. Here are the webinars. So if you look on this, this is on progress at the moment. That's what Leigh and I are doing. But next week is a beautiful one on gravitational waves. So we got a lot of science here. And then Dr. Diana Hooper is coming back next year. She's so brilliant. She's coming back. She's going to talk about the early universe, really exciting. And we're going to put up on every week, we're going to come up with interesting webinars. So this doesn't cost anything, but you really, try and support us a bit, because iTelescope is still a not-for-profit organization. We put everything that we gain, we put back. So if you support us in some way, you really benefit the whole community, and it also makes it possible for us to do these things. Right, now I'm going to try and do the impossible again and try and find, yeah, stop sharing. You see now have I stopped sharing? I don't know.
Yes, yeah, you stopped sharing.
Oh yeah, because here I have the same problem again. I don't know, Leigh, where you've gone, but I cannot find you anymore. My computer has, oh, there you are. The computer slowed down again. So sorry about that. So I'm just going to stop the recording.